Hello everyone, welcome to lesson number 11 for BC Calculus. In this lesson we're going to talk about the indefinite integral and the definite integral. For lesson number 10 we talked about the Riemann sum. Riemann sum, we used the left, right, midpoint, and trapezoidal approximation to gather some information about what would be underneath the curve, like what's the area going to be. And in that actual video we talked about a function, right? So our function would be f of x, which is right here, and we looked at it on an interval from A to B, and we wanted to find the area underneath the curve. We want to know what this was. Well, what did we do to find that? So what we actually did to find the area between the curve is we took rectangles, right? We took a little rectangle, and we actually were able to find the width of the rectangle, which was our delta x, and the height of our rectangle actually represented the height of the function, right? Which is where we hit the function. So when x equals this value here, the height would be f of x right there. So that's how we get that. Well, when we're actually asked to calculate integration, the function, as you see right here, is this, and then delta x is going to be, again, the width of the rectangle. The little s thing, so the little sigma part of this, that's going to be taking all of the individual rectangles, so all the rectangles that you did underneath the curve, and we want to add them up. We want to do the sum of these areas. So this s stands for sigma, which is the sum of our functions. So all these rectangles that we add up, this is going to be the sum of them. And then our function is going to be the height of the rectangle, and then the width is going to be the delta x. And so that's how you see that. That's why there's a delta x for all of these problems, because that always represents the width. And then the function tells you, okay, at x equals blah, blah, blah. What is our function? What's our height going to be? So now what do we want to do? So how do we want to actually integrate this? Well, it says complete the following integration formulas by reversing the derivative formula. So this is, I've already wrote this out for you guys. So using the power rule, right, using the power rule, to take the derivative of x to the n, that's just nx to the n minus 1. So what I want to do, ladies and gentlemen, is I want to actually integrate this. So this is my function, and here's my delta x. And so I want to basically make this look like this again, right? Make this look like this again. Well, the first thing I can do to get rid of the minus 1 here is go ahead and add 1 to our exponent, right? So if I go ahead and add 1 to our exponent, that's going to give me back x to the n, right? Because the negative 1 and the 1 cancel. So if I want to take x cubed and I want to integrate it, I'm going to go ahead and get a plus 1 here. So I have a x to the fourth, right? I have an x to the fourth. Now, we know that we have to do a little bit more than that, because if I take the derivative of x to the fourth, I get 4x cubed. Well, I have a 4 here that I don't want, right? If I take the derivative of this, I get 4x cubed. Well, there's no 4 here. So what I need to do is I need to divide. Now, most people think you're going to divide by n. Well, remember, that's not what I want, because the n is actually going to be 3. So what I want to do is I want to add n plus 1. I divide by the exponent, what our new exponent is, right? Our new exponent is going to be 4. So I want to divide by 4, and I want to divide by 4. So then I have my function is x to the fourth over 4. Now when I take the derivative of this, I move the 4 down. The 4's cancel, as we should expect here, x to the 1 less power. And so that's the idea. And we're going to do a plus c, and this plus c just basically means that I have some constant. I may not have a constant, but if I had x to the fourth over 4 plus 5, then the derivative of x to the fourth over 4, again, is x cubed, and then plus the derivative of 5 is just 0. So this plus c just means that I could have a constant here, I'm not sure. I can have a constant here for that, I'm sure. So let's use the same logic for this number question right here, and I'm going to rewrite this as the integral of x to the negative 3 dx. And so what I'm going to do to find this problem is I'm going to write down for us our actual function of x, and I'm going to go ahead and add 1 to the power. So I'm going to add 1 to the power, I'm going to get a negative 2. Then you're going to divide by whatever that exponent is. Okay, so you're going to divide by that exponent, negative 2, plus c. That's going to always be a formula. I'm going to write down the formula here in a second. But whatever this exponent is here, you're going to also divide by it. I want to simplify this. I've got a negative 2 in the denominator, right? A negative 2 in the numerator. Let's go ahead and make the negative go up here. I'm going to move the x to the negative 2 down, and I get negative 1 over 2x squared plus c. So what's our general formula? What's the general formula for finding an integration of x to the n power? Well, you're going to take x, and you're going to do n, and you're going to add 1 to the power, and you're going to divide that by n plus 1. So that's our formula. That's all that you have to do here. So x to the n plus 1, we're going to add 1 to the exponent, and then whatever our new exponent is going to be, we're going to divide by that, and then we're going to do a plus c for, again, the derivative of a constant will go away. So let's look at this particular example right here and see if we can figure out what to do. So for negative x squared, okay, and just like with derivatives, we can actually integrate these separately and still be fine with it. So for negative x squared, we're going to go ahead and do negative x, and we're going to add 1 to the power, which is going to be 1. 2 plus 1 is 3, and then whatever that exponent is, we're going to divide by 3. There's our derivative. There's our derivative for negative x squared. It's that simple. Leave the constants alone. So we haven't had one with a constant yet. So let's go ahead and do 4x. We're going to add 1 to the exponent, which is 2, and then we're going to go ahead and divide by 2 as well. And so this will simplify down to 2x squared. Minus 3. Now this is really x to the 0, right? X to the 0. So we're going to go ahead and do x to the 1. And then we're going to go ahead and divide by 1. And then we're going to do a plus c. So with this being said, this answer is going to be negative 1/3 x cubed plus 2x squared minus 3x plus c. And if you were to take these derivatives, you get this back. You get this back. So that's really all that you have to do for this problem. For example, number 2, you would rewrite this as 3x to the negative 2 plus minus 1 dx. And so let's do this one pretty quickly. And so we're going to have 3x. We're going to subtract 1 from the power. We're going to get negative 3. Whatever you have as your exponent, you're going to have it in the denominator. And then it can be negative. And then the integration of some constant. So we should say the integration of some constant is just going to be that constant with an x. Right? So the integration of negative 1 is just going to be negative 1x. The integration of negative 3 is just negative 3x. So we're actually adding it back. Right? Adding back. I'm going to do plus c. Okay, so let's look at example number 3, and don't let the fractions bother you. You do the same thing before. So we're just going to go ahead and write the constant out, because the process is the same thing, no matter if it's whole numbers, fractions. So 3/4, you're going to do x, you're going to add 1 to the power, which is going to be 6, and so whatever that number is, you're going to also divide by that value. So this fraction is going to be 3 over 24 x to the 6, which is 1/8 x to the 6, and that's it, ladies and gentlemen. So then we're going to do plus. We're going to do 5 over 3. I always like to put the x with the 5 because I can put the number down here, right? So times. So x, we're going to add 1 to the power. We're going to get a 3 here. So we're going to divide by 3. So this is going to be plus 5x cubed over 9. And then it's going to be negative. I got a 1/2. I got an x. I'm going to add 1 to the exponent, which is going to be 2. As soon as I put a 2 here, I'm going to multiply 2 here. So I'm going to get a negative 1/4 x squared plus c. That's all you have to do. So again, do not worry at all about the fractions or coefficients or whatever it is. Okay, so let's look at question number 4. So question number 4, you're going to learn something very soon called use substitution. And that's how I would absolutely tell you to do this problem. But right now, we're not learning that. We don't know that. So we're going to go ahead and expand. So we're going to just rewrite this problem as 4x squared. We're going to multiply and double 4x plus 1 delta x. And students ask, parentheses, not parentheses. I always like to put parentheses around it, but you don't have to. And now, ladies and gentlemen, we do the problem like we did in the first 3 examples. We're going to write the 4 down. We're going to get x. We're going to add 1 to the exponent, which is 3. So we're going to immediately put a 3 in the bottom. We're going to do minus 4. We're going to do x. We're going to add 1 to the exponent, which is 2. So we're going to put a 2 in the bottom. The integration of 1 is just 1x. And then we have a plus c. And again, you can simplify that if you want to. So that's how you do that problem. And then example number 5, our last very nice little example here. It looks really crazy. It looks really crazy. However, and we don't know how to do this one yet, but we can use identities. We know that sine squared x plus cosine squared x is equal to 1. Therefore, 1 minus sine squared x is actually equal to cosine squared x. These cancel out, so you're left with the integration of 1 dx. So this answer is going to be x plus c, because the integration of 1 is x, and then we have to do plus c. So this crazy thing right here is just going to be x plus c. All right, so for example 4 and 5, the process is just please make sure that you guys simplify your work. All right, ladies and gentlemen, so we're going to finish this video up by talking about some rules here for a second. So whenever you integrate something, you get the function back. I'm not a big fan of little f versus big F, so an example that I want to show you that you guys can relate to very well is if I ask you to integrate your velocity function, then you're going to get the position function back plus a c for some constant. So again, you take the derivative of this, you're going to get this back. Okay, that's what you're going to get. So let's look at these differential and integration formulas. So this we've already talked about in previous lessons, unit 1. So when you integrate 0, right, you're going to get c, because anytime that you have a derivative of a constant, it's just going to be 0. If you're trying to integrate a constant, so any constant, 3, 5, 7, 9, whatever, it's just going to be that constant times x, and then plus c. And then if you are going to integrate a constant with a function, and this is very similar to taking the derivative of a function, right? If you're going to ever integrate 5 times f of x dx, you can always, and this is really important to understand, you can always take a constant out of the integral, always and forever. Always and forever. Then the last thing down here is what we just did. If you want to integrate pieces that are adding and subtracting, all right, adding and subtracting just like we did in these examples up here, right? I'm adding or subtracting these terms. I can integrate them separately, and then put them back together at the very end. So if I can integrate f of x plus g of x, I can integrate f of x separately from g of x and then put them together. And then this, ladies and gentlemen, is going to be the sum. This is going to be our rule, our rules that we can have right here. Okay, so that is going to be the end of our first video. So hopefully that makes sense, and I'll see you guys in video number 2.